cream company has determined that at a price of $4, the demand will be 4,000 sundaes, and for every 25-cent decrease in the price, the demand increases by 200 sundaes. So we begin by expressing the demand as a function of the price. So I begin by putting in what I know in this table. So at $4, the demand, the quantity would be 4,000 sundaes. And if I drop the price by 25 cents to $3.75, then the new demand will be 200 sundaes more at 4,200 sundaes. So then I execute the linear regression command. So on the calculator, what I did to find the equation, I would hit stat and then press enter, and I would enter into the list L1 and L2 the prices and the quantities respectively. So here I've got 4 and 4,000, and then $3.75 and 4,200. Then I would press stat, arrow over to to calculate. Option number 4 is linear regression, so I just press number 4. Make sure the input list, the X list, is the price list. That's my L1. And then the Y list would be the quantities, the output in L2. Then I'll just go down here, calculate. And here I have y equals ax plus b. A is the slope, so negative 800 is the slope. So I have negative 800p. And the intercept is 7,200. And there's my 7,200. This is how we achieve the demand function using the calculator. Now the revenue, which is always price times quantity, we simply substituted in for Q what Q is equal to in the demand curve. So to express the revenue as a function of price, it's equal to price times quantity, but now we express the quantity as negative 800p plus 7,200. So this is my revenue function. Now to find the maximum revenue and the price at which it will be achieved, I'm going to graph this function. So what I will do, press y equal, and then enter in the revenue function as you have it in part B. And then for my window, I thought Sunday shouldn't cost any more than $10. And then knowing that 4 times 4,000 is already 16,000, I'm going to set a Y max of around 20,000. That's a little bit more. If I need to go higher, I can always do that in a minute. And so if I use 0 to 10 for the inputs, the X values, the prices, and 0 to 20,000 for the outputs, the quantity or the actual revenue, I'll press graph, and I end up with a function that looks something like this. And to find out where it attains its maximum value, I'll press second and trace for calculate, then choose option number 4 for maximum. Want to make sure that the revenue function that I'm maximizing shows up here in the top left hand corner, and when it does, if not, I would use the up and down arrow keys to find the right function. But I'm going to then answer the questions. First, it asks for a left bound, so I need to move the cursor off to the left of where it reaches its maximum and press enter. Now it asks for a right bound, so I will press the right arrow key until I move to the right side of where it reaches its maximum value, and then I'll press enter. It will try to find the maximum revenue between these two points, these two triangles it creates. And so I can choose a guess or just press enter, and it will lock in on the value at which it attains its maximum value. In this case, 4.49999 approximately rounds to $4.50. And then the output, which is the revenue, the maximum revenue in this case, is 16,200. So that's how I achieve this point. So answering the questions, find the price that will maximize the revenue. That would be $4.50. The maximum revenue is actually the $16,200. You could have found the number sold by just substituting in the price and revenue that you know and finding Q, or in the demand curve, plug in the price of $4.50 to get out the quantity demanded. So that's how we use the calculator in solving this problem.